Hey guys, today we're going to be talking about primes. Let me just do a quick recap on prime numbers. So prime numbers are numbers with only two factors, 1 and itself. So for example, if we have the number 13, the only way we can get to number 13 is by timing 1 times 13. Do you see? 1 and itself. And on the opposite side, we have what's called composite. So composite numbers have more than two factors. For example, we have 6, and we can build a little T-chart for this. We can multiply 1 in itself to get 6. And then another way we can get to 6 is also 3 times 2. So because 6 actually has 4 factors, it is no longer a prime, it is called a composite. So the divisibility rules, if you don't know what it is, the root word is divisible. That means it has to do with something dividing. To see if a number is divisible by 2 is that if it ends in 0, 2, 4, 6, and 8. Did you notice in my 2's facts family, it ends in 4, 6, 8, 0, 2, 4, 6, 8, 0. These are all what we call even numbers. Any number that is divisible by 2, it is most likely will be also divisible by 4, 6, 8, and 10. Now, in order for us to see if a number is divisible by 3, we have to add the digits together. And I'm going to show you in a little bit how that works. And then after you've gotten the sum of the digit, you're going to divide it by 3. And if it divides evenly into 3, then that number is divisible by 3. And any number that's divisible by 3 will most likely also be divisible by 9. Another rule that is easy to remember is 5s. Notice how my 5s right here, all of my facts end with either 0 and 5. So any number that ends with 0 or 5 is divisible by 5. And 10 is also kind of the same thing. Notice the ending numbers all ends with 0. With this said, when we're looking for primes, the only thing that you will actually have to divide are to test our numbers 7, 11, and 13. So now let's go ahead and see how we can apply this to find prime numbers. So as you can see, I have a divisibility rules right here, and I also have my multiplication chart to help me. For today's example, we're going to work with numbers 30, 23, and 93 to see which ones of these are prime or composite. Now let's look at 30. Smart student would actually use the divisibility rules first. One thing that I noticed about 30 is that it ends with a 0. That means it's divisible by 2, 5, and 10. You know what? The minute it's divisible by any other number but 1, it is already a composite. Now let's look at 23. 23, I look at the ending and I see that it doesn't end in an even number, so I know it's not divisible by 2, 4, 6, 8, or 10. Notice how many numbers we've just eliminated just by looking at that ending. Then we're going to check to see if this number is divisible by 3, and how we do that is we're going to add the two digits together. When you add these two digits, you're going to get 5. And we're going to ask ourselves, is 5 divisible by 3? And we don't see 5 in the 3's facts family, so we're going to say no. Because of that, this number is not going to be divisible by 9 as well. We look at the ending again, and we don't see that it ends with a 0, so we know it's not divisible by 5 nor 10. Now let's see if it's actually divisible by 7, and we have to actually divide. So let's see if 23 is in here. Nope, it's not. So it's not divisible by 7. Is it divisible by 11? 23 is not in here. Nope. Now if I extend my chart to 13, my next fact will be 26, because 13 times 2 will give me 26. Again, 23 is not in the 13's facts family. So I know that 23 is prime. Now I'm going to pause right here and I'm going to show you how to actually use the multiplication chart in this case, because this is such a small number, like 23 is a small number. I'm going to show you how to actually quickly use the multiplication chart to find that 23 is prime. Here's how. Notice how I ran a line across and down here. What I'm trying to do is I'm trying to separate counting numbers. So all of this in the gray shaded area, just my counting numbers. These are the facts family of 1s, 2s, 3, 4, 5, 6, and so on. Now anything that's in this area right here, in order for them to be present in this area, they must be a multiple of two different numbers. For example, 4 is a multiple of 1 and 4 and also 2 and 2. That tells me that 4 is composite. Anytime when you see a number in this area right here, they are all composite. So let's try 54. Let's go ahead and create a T-chart for it. We know that 1 times 54 are 2 factors. We also know, because it's here, that you can also have factors of 6 times 9. And the minute we can prove that this 54 is divisible by another number other than 1, it's already a composite number. We don't have to do anything else. In this case, let's try to see if we can find 23. Let's see, I see 20, no 23, no 23, no 23, so on and so forth, no 23. You will not see 23 anywhere in here. So therefore, this number is a prime number. Now let's look at 93. 93 is the one that I would use divisibility rules for, just because it is a bigger number. And look at the ending again, and it doesn't end in a 0, 2, 4, 6, or 8, so I know it's not divisible by 2. Let's see if it's divisible by 3. If I add these two digits together, what do I get? I get 12. 12 divided by 3. Let's see, we're in the 3's family. 12 is one of the facts in the 3's family. So I know that this number is actually divisible by 3. So this tells me that this is a composite number. Alright, let's review. Well, first of all, we have prime numbers which have exactly 2 factors. Our example is 13 because the only way you can multiply 2 numbers to get to 13 is by 1 times 13. It only has exactly 2 factors, so therefore it's a prime number. Our other number is called composite numbers. These are the numbers with more than 2 factors. And in our example, we have 15 because there are a couple of different ways you can get to 15. You can either multiply 1 times 15, or you can multiply 3 times 5, which means 15 has 4 factors. Therefore, it's a composite number. There are a few helpful tools to help us with how to find composites and primes. And one of the beautiful tools, as illustrated in the video, is a multiplication chart. Or you can also use the divisibility rules. This works beautifully for numbers that are big numbers. I also attached the notes to the divisibility rules in the comment section for your convenience in case you want to print it out and study it. Well, good luck with all of your primes and composites. Have a great day.